Okay guys, so here is the video for the notes for lesson 81. Lesson 81 is due 4/13. That's Monday. It's due Monday. Okay, this is the natural log, using natural logarithms, that ln that I've already shown you. So we're going to go over that again, talk about it a little bit more. Natural logarithms, that's the ln. The base for ln is e. So if you've got a natural log, the base is e. So if you have something like, let's see, ln e to the x, that's going to equal x because ln e cancels each other out. They're inverse operations. You could also see something like e to the ln x equals x. Yeah. Because these have the same basis, so they cancel out. So x equals x. And it's because they're inverse operations. That's why it happens. So that's going to help you out on number 7 in the homework. Okay, so what you're going to see is you're going to see things like e to the ln p. And since these are inverse operations, so this is in the exponent, but since these have the same base, because there's a little e right here, we just can't see it, because we just assume it because it's a natural log. So these cancel out, you're left with p. If you have e to the ln 2x, the e and the ln cancel, and you're left with 2x. So it can either look that way, or it can look like natural log of e is 3c squared plus 1. So natural log of e, already talked about it. We've talked about it before. That cancels. You're left with 3c squared plus 1 for that one. And then you can have natural log e of 2d squared plus d. So the natural log e cancels, and you have 2d squared plus d left. Okay, so that's the first thing. And again, it's because they're inverse operations. They are inverses. And so that's why they cancel each other out. Okay, then we're going to have to use the properties and laws of logarithms to rewrite things as sum or differences. So what you've got to remember is if you multiply your arguments, this is the argument, that means you add them separately when you break it up. So you're going to take something like this and you're going to break it up into the addition. Okay, writing it as a sum or a difference. And then if you have a fraction, that means it's subtraction, or subtraction makes a fraction. So if your argument is divided, it's going to be subtraction. And then if you have your argument with an exponent on it, that exponent comes to the front. So the p, I kind of wrote that weird, and I wrote a weird. Let me make that better. The a is bigger, and then p is the exponent on a, and then you put that in the front. Okay, so you've got your addition or your sum, your difference, and then a product. So then what you're going to be asked to do is write as a sum or difference. So you're going to be asked to write it as a sum or a difference. And you'll start with something like ln 6e, natural log of 6e. So what you want to do, since this is multiplication, you're going to break it up. You're going to break it up to ln 6 plus ln e. You're going to break it up into that. And then reduce anything you can. For example, ln e is 1. So ln 6 plus 1. Now we've talked about ln e being 1 before and ln e canceling out that kind of stuff. So this is what you would be left with. So you're going to start with something small and you're going to end with something big. Okay? So ln 10e. So again, I'm multiplying, my argument is being multiplied, so I break it up into an addition. So ln 10 plus ln e, and then fix, reduce anything I can, so it'd be ln 10 plus 1. Okay, so let's try some more of those, breaking those up into sum or difference. Let's see, we've got ln 3e over x. ln 3e over x. So you've got two different operations going on here. You've got a multiplication, which means it'll change to addition, and you've got a division, which means it'll change it to subtraction. So you would have ln 3 plus ln e minus ln x. That's how that would break up. These two are being multiplied, so they're the addition. They're being divided by x, so that's your minus ln x. Fix anything you can. So ln 3 plus 1 minus ln x is how that would finish, how you'd finish out that one. Then you'd have ln 5e over y, just showing you a lot of examples of these. Excuse me, sorry. So you can do your practice easily and your lesson. So it'd be ln 5 plus ln e minus ln y. ln 5 plus ln e minus ln y. So ln 5 plus 1 minus ln y is how that would be. Okay, then they just kind of get more. So ln e to the 5x squared. So if you see it like this, guys, remember about the ln e. Don't make this complicated. Don't move this to the front. I'll show you both ways. We've already talked about how ln e cancels, so it's 5x squared. If we follow the properties of logarithms with this, when that's an exponent, it moves to the front of ln e, but then again, ln e cancels. So either way, you get 5x squared, okay? So let me show you that again. Let me show you both ways. Okay, so this one already has a 3 in front of it, so you can do it two different ways. You can remember, this cancels. It's a 1. It cancels. So 3 times 6x squared is 18x squared. Or you can follow the properties of logarithms. So you either see that ln e is an inverse and cancels itself out, or you can remember your rules and properties of logarithms where you would move the 6x squared in the front. So it'd be 3 times 6x squared ln e. Either way, guys, the ln e cancels, and you're left with the 3 and the 6x squared. So it's 18x squared. Either way you do it, okay? Wanted to show you both ways on that. Then right now, the most complicated one you'll have is something like this. Natural log of 2x cubed over e to the 4th all squared. Something like this is the most complicated one you'll have. Now there's two different ways to approach this, and we're going to follow the rules and properties of logarithms. So we're going to move that 2 in front. The thing we have to remember about it is that it's going to have to distribute to everything in here, okay? So let me rewrite this for just a second. And then we've got exponents that we're going to have to take care of in the problem as well, okay? In the argument as well. So we've taken care of that too, moved it in the front. That's the product rule of natural logarithms, well, really of any logarithms. So now these are being multiplied, so they need to be added. This is being subtracted, so it'll be a minus. So I'll have 2 ln 2 plus 2 ln x cubed plus 2, actually not plus 2, sorry, it's a minus, minus 2 e to the 4th, ln e to the 4th. Okay, so hopefully you're asking yourself, where'd you get the 2 from? Where'd you get that 2, those 2 from? From this 2. I said it had to distribute. So it's got to distribute to the ln 2. So this 2 and ln together have to distribute to the 2. They have to distribute to the x cubed, and they have to distribute to the e to the 4th. Okay? So that 2 and that ln are connected, and they go to everything in the argument, to the 2, to the x cubed, and to the e to the 4th. Then we come and fix anything we need to fix. Nothing needs to change on the first one. I always start writing my ln's wrong. On the second one, that 3 that's an exponent needs to move in the front, so you'd have 3 times 2 ln x, which would give you 6 ln x. And then on this one, like we've just talked about, showing it to you again on the rest of the picture, ln e cancels. and 2 times 4 is 8. So there's your simplified one. That's as complicated as it's going to get. Is that right there? Okay, so let me show you another one, like that one. Let's see, ln 5e squared over v to the third all cubed. So ln 5e squared all to the third over v cubed. So these are being multiplied, so they're going to be added. This is being divided, so it's going to be subtracted. And then the 3 goes in front, so 3ln, and then 5e squared over v cubed. So some of you could probably do what I'm doing in 2 steps and 1 step. I don't care. As long as you show me what you do, I'm fine, okay? So then I'm going to rewrite 3ln 5 plus 3ln e squared minus 3ln v cubed. Again, that 3ln has to distribute to the 5. It's not really distributive property, but I think that's a way you can remember it, that the 3 and the ln both go to everything in parentheses. So 3ln 5, 3e squared, 3ln e squared, and 3ln v cubed. Then you fix anything you need to fix. 3ln 5 doesn't need to fix. That 2, well, actually, the ln e cancels. So that's just 6, because 3 times 2 is 6. Minus, on this one, this 3 right here needs to come in front. So you'd have 9 ln v. And that's your final answer. There's not any particular way to write it. Like, this order doesn't matter. Just make sure you got your signs right. Okay, so that's that stuff. Then we go into the growth and decay. That AT equals AOE to the KT that we've already talked about. Okay, so we're going to review this. We're going to talk about half-life and what you have to write on half-life. Now, the book uses this one, NT equals NO e to the KT. That is not used very often in other books. In other math classes, you won't see it written like this. You'll see the A one. So we're using the A one. So I do not want this one. The book may tell you to use this one. I don't want you to use this one, okay? We're using this. And if K is positive, so if you've got a positive K, that means it's growth. If you've got a negative K, that means it's decay. When you're talking about a half-life, you're talking about decay. So half-life, your AT is going to be 0.5. So you're going to put a 0.5 in every time for half-life, okay? To start out to find K. Because remember, when we've done these before, we always need to find K first. And K will be negative. On a half-life, K will be negative. You'll have a negative K. It'll work out in your calculator for it to be negative K. So in your book, you'll be looking at example 3, because I'm not going to show you exactly the way the book does. Is one, they're using the N thing, and another one, they set it up with a negative K on it, which you don't have to do. So we're always using AT equals AO e to the KT. That's what you're always using. AT equals AO e to the KT. And you're given that thallium is a radioactive substance that can be injected into the blood as part of a health test for the heart. It's then tracked through the heart. Thallium has a half-life of 73.1 hours. How long will it take for 1 gram of thallium to decay to 0.1 grams? So thallium has a half-life. So that means you're going to put 0.5 right here. Your AO is 1. We just assume that right now, that AO is 1 because we're given a half-life. E is just E. We want to find K, and my half-life is 73.1 hours. So there's the 73.1. Now you go through like we've done before. 1 times E is just E. So go ahead and just take the natural log of both sides right now, which is something we've done before. That is not new. That should not seem new. That is not new. And again, cancel out. Already talked about that. So right now I'm left with ln 0.5 equals 73.1 K, and then I divide by 73.1. Whoops, got too many decimals in there. 73.1. So then K is about Okay, you'll have to go on and check with me because I put this is what happens when you don't keep all your stuff together. So you get a nice view of my floor. Sorry, guys. Okay. Yeah, didn't have my stuff together. So ln5, close parentheses, divided by actually ln 0.5, because this is a half-life, divided by 73.1, gives you negative 0.00948. Negative 0.00948. So then what we do now is we want to find how much is left over we want to find out how much is left over, or how long. We want to find how long it's going to take for 1 gram of thallium to decay to 0.1 grams. So our AT is 0.1 because that's what we want it to decay to. We're starting with 1 gram and we want time. So E, my K is negative 0.00948 and I want the time. So you solve for T just like we did K. So 0.1 equals, actually, we just need to go straight to taking the ln of both sides because 1 times E, or we could divide by 1, because if it was anything but 1, we'd need to go ahead and divide by it. So then you take the natural log of both sides. So then ln E cancels, so you get natural log of 0.1. Whoops, not 8. Natural log of 0.1 equals negative 0.00948t. And then negative 0.00948, you divide. And then you're going to round to whatever you're asked to round to, which on this, in the book it rounds to the nearest tenth, so unless it specifies, you probably ought to give 2 decimal places. So natural log of 0.1, close parentheses, divided by negative 0.00948. And then you get 242.9. I think that's minutes. No, started out as hours because it was 73.1 hours. So it would take that many hours for 1 gram of thallium to go away, okay? So that's the way you do that, and this is what you're going to follow. You're going to follow this example just like this for practice G. So you're going to follow this for practice G, just like I've shown you. You're going to use this. It gives you a half-life on G, so you're going to use the 0.5. It gives you the half-life is 42.3, and you want to know how long it will take for 200 grams, so that's where you start with to decay to 5 milligrams. So over here on this one, you want it to decay to 5, and you're starting with 200. So on practice G, this would be 5, this would be 200 after you find K. After you find K. So you'd have to divide by 200 first, get the E with the K by itself, and then solve for T. But that's the way you do practice G. And we've talked about this before. We've talked about this exponential growth and decay before. So that should be a review for you. So you're going to do, on this lesson, you're going to do the warm-up, which is on page 574. You're going to do practice A through G. So, lesson 81, warm up on page 574. And then the practice A through G. And then, let's see, you're going to do 1 through 7, 13, 14, 17, 19, 21, 22, 24, 27, and 28. 1 through 7, 13, 14, 17, 19, 21, 22, 24, 27, and 28. Okay, and there's a couple of things I wanted to talk about on those. So let me see which ones. On number 1, just find the inverse. Number 2 is using the z-score. It's a formula. Number 3, you've got y equals negative 4 square roots of x plus 2, and you're asked to find the domain and range. To find the domain, what's underneath the radical has to be greater than or equal to 0. It has to stay positive, or 0. So we subtract 2, so x is greater than or equal to negative 2. That's your domain right there. Then for your range, there's a couple of different ways you could do it. You could put in this negative 2 right here. That'll give you a 0. Square root of 0 is 0, so it zero it out. The thing you need to watch out for is that negative, which means this is going to be going down, so your range would be less than or equal to 0. Because all this can be a 0, because the smallest x can be as negative 2. If you put negative 2 in, you get 0. Because of that negative, it opens down. Or look at it on your graphing calculator. So if I go to y equals, and I put in the negative 4 square root of x plus 2 and graph it, see how it's going down? So that means your range is all less than or equal to 0. Okay? And I know it doesn't touch the x-axis, but that's just what happens with the graphing calculator. But it is y less than or equal to 0. That's your range. Okay? And it's because of that negative. So that negative in front causes the range to be less than or equal to whatever this number is. So if you put your smallest number in for the domain, which is negative 2, you get 0. Because of that negative, y is less than or equal to 0 on the range. Then on number 4, you've got y equals 1/2 square root of x. So your domain is just x greater than or equal to 0, because that has to stay 0 or positive. Then on your range, it's y greater than or equal to 0, because if I put the smallest x can be in at 0, square root of 0 is 0, 0 times 1/2 is 0. There's no negative here, so my range is positive. So that means this, just kind of sketching it, would go up like this, something like that. That's not exact. I'm just showing you that it goes up, so your range would be greater than or equal to 0. So that's 3 and 4. That should help you on 3 and 4. 5 is just like the notes. On 6, on number 6, you've got this triangle here. They give you the triangle. This is a square root of 187.23. This is 15.8. And this is 7.9 centimeters. And you're asked to find C. So there's a couple of different ways you could do it. You could use inverse sine, inverse cosine, inverse tangent. You could do this. Or you could use law of cosines, because you've got the side links. You've got the side links, so you could use any of these. Inverse sine, inverse cosine, inverse tangent, or you could use law of cosines. So you can look those up, but I'm telling you those are your choices, okay? Those are your choices, what you can do on number 6. Number 7 I talked about in the notes. Number 13, okay, number 13 and 14 are both completing the square. So I want to show you. Okay, so I'm going to show you 13 and then follow what I do on 13 to do number 14. So 2d squared minus 10d minus 8 equals 0. That's the first thing I'm going to do. Because if I want to use completing the square, I do not want a number in front of my d squared. So I'm going to divide everything by 2, which is nice. Everything is divisible by 2. Notice how I also divide the 0 by 2. I have to. So it'd be d squared minus 5d minus 4 equals 0. Okay? So this doesn't factor. You can't factor in anyway because the instructions are used completing the square, and you need practice remembering completing the square. And that's why I'm doing this. So you move the 4 over. So it was a -4 here, it's a +4 here. You take the 5, you divide by 2, and you square it. Now 5 is not divisible by 2, so that's not fun, but you can still do it. So 5 over 2 squared would be 25 over 4 and 25 over 4. We add it to both sides. You got to make sure you add it to both sides. So then this side would be d minus 5 over 2 all squared. Then here, the easiest way to do this right here is to do 4 times 4 plus 25. Because you got to find a common denominator, which means you're doing 4 times 4 anyway. Or you could have 4 and 25 over 4 as an improper fraction. Well, not as an improper fraction, as a mixed number, which is not correct. So you'd have to fix it. So 4 times 4 is 16, plus 25 is 41. So this would be 41 over 4. Then you take the square root of both sides, which we've talked about before. So d minus 5 over 2 equals plus or minus square root of 41 over 2. Because the square root of 44 is 2. So I have to take that square root. Then you're going to add 5 over 2 to both sides. So d equals 5 over 2 plus or minus square root of 41 over 2. Now again, if you got lost on that, stop. Stop the video, rewind it, go through it again. You're going to follow these same steps on number 14. Number 14 follows the same thing. I think on number 14 you can divide by a 3. You've got a 3 in front of that quadratic term, in front of that squared term. So you just need to divide by 3. And then I think it's nicer, yeah. Because the middle term you get when you divide by 2 and square it is divisible. Okay, number 17 is not a big deal. Number 19 is not a big deal. 21 is finding the discriminant again. We did that. You also have one of those on your review that I did for you, so you could look at it as well on 21, that review for test 15. 22 is what we did on the notes. So follow the notes, follow the practice to do that one. Now on 24, it says you've got NT, which I hate that. NT is the same as AT. So really your AT is 0.3, your AO is 1, and your K is 0.0974, which I don't like that because they tell you to write a decay function. Well, if you write a decay function, K has to be negative. So if I'm plugging into AT equals AO e to the KT, that means 0.3 is here, AO is 1, E, my K is negative 0.0974T. So there's the setup. Now you solve for T. Okay, you go from here and solve for T, following the notes, following what you've done on the practice, that kind of stuff. Okay, so that's 24. 27, you're using law of cosines. You're finding side C using law of cosines, so that's what number 27 is, law of cosines. And then on 28, I want to go ahead and start the bell curve for you, because on 28, all you have to do is draw the bell curve. So it's the height of children. They're normally distributed with a mean of 42, so 42 goes here. And then a standard deviation of 2.2, so standard deviation is 2.2. So that means you need 3 standard deviations, so you add, so 44.2, and then you subtract, which would be, so I don't get it wrong, 42 minus 2.2, 39.8. And then make sure you put the percentages in. You've got 3 percentages to put in, and you got to put these other numbers. So you need to add 2.2 again and again, and you need to subtract 2.2 again and again and put the percentages in. And that's it on 28. You just have to draw the bell curve. So it started for you there, you finish it. And again, this is not due until 4/13. This isn't due until Monday.